Good afternoon, ladies and gentlemen, and welcome to this fourth webinar on carbon capture, utilization and storage organized within the ECCSELERATE project. So the topic of this webinar is sustainable CCU technologies relevant for Europe and ECCSEL. So just few words to introduce ECCSEL, which is an European network with more than 80 world-class research facilities owned by 23 between research center, companies, and public institutions. Scattered in France, Italy, United Kingdom, Netherlands, and Norway, which hosts the operation center. Basically, the focus, the main goal of ECCSEL is to close the CCUS knowledge gap, to contribute to the reduction of CO2 emissions in accordance with the targets of the different countries, and of course the final aim is the reduction of global warming. Basically, this webinar is organized within the ECCSELERATE project, which is an Horizon 2020 project managed by ECCSEL, with the aim to basically, with the aim to increase the availability of international infrastructures for CO2 carbon capture, utilization and storage research, in order to promote the international collaborations and, of course, to develop technologies for CCUS. Basically, this project includes a capacity building program with a series of webinars. This is the fourth one. Several specific workshops organized in conjunction with the popular summer schools in Panarea and Sulcis, and tailored training courses, in particular with the aim to attract industries, research, and new user groups to ECCSEL. So, as mentioned, this is the fourth webinar of this series. The first two webinars have been organized in late 2020, focused on CO2 capture and transport. A third workshop has been organized in February on CO2 geological storage, and this is the fourth one, the fourth webinar focused on CCU, as mentioned. So, just a couple of recommendations for this webinar. Please switch off your microphone and camera during the webinar, and after we have two presentations, and after this presentation there is a session dedicated to questions and answers. So please type all your questions in the question panel, and at the end of the presentations the speakers will answer you. So we can start with two presentations. So the first speaker is Anastasios Perimenis, who is the Secretary General of the CO2 Valley Europe Association. And the second speaker, after Anastasios' presentation, the second speaker is Elvia Chavez, research scientist from Sintef Energy Research. So let me thank you for your participation, and Anastasios, please, the virtual floor is yours.
Hello, Alberto. Thank you very much. I'll just need to open up my screen. I hope you can see it. If you can't see it, then please give me a sign.
Yes.
So thank you for having me today here to explain who we are, what CO2 value Europe is doing, and describe a bit the progress of CCU in the European context. I will briefly describe also who CO2 value Europe is, because we're new to ECCSEL and we might not be known by the stakeholders of the ECCSEL consortium. But first, I would like to say a couple of words of why this workshop is important, why CCU is important. And if you can see the right part of the screen and check the chain of CO2 valorization, capturing it from point sources, from flue gases, or directly from the air, adding renewable energy whenever it is needed, and proceeding with the conversion part to give an array of products, of marketable products like building materials or chemicals or fuels. So in this whole process, in this whole valorization of CO2, CCU can contribute to achieving net zero emissions, even negative emissions, depending on the pathway. For example, direct air capture to a permanent storage in building materials. Importantly, it provides an alternative carbon feedstock. So there are not many alternatives in terms of carbon feedstock compared to fossil origin. You have biomass with sustainability constraints, you have recycled plastic, and then you have CO2. So that's why we don't really talk about decarbonization when we're talking about CCU. We're talking about defossilization, providing an alternative carbon feedstock for our everyday products in principle. At the same time, as the picture shows, we are by definition contributing to a circular concept, to the circular economy, by not only by reusing an emission and transforming it into a useful product, but also in terms of waste materials that can be used as inputs when we're doing CCU process. So it's a double circular concept for the emissions, but also in terms of waste management. In that sense, we are hoping that we can drive the efforts of the industry to become more sustainable, more resilient in the future years by reducing their carbon footprint, by making new and more robust alternative business models that are based on non-fossil resources. Since some of the CCU processes do require energy, this energy, it is important that is of renewable origin, so that the whole carbon footprint makes sense and is lower than the footprint of an alternative conventional product. In that sense, CCU processes can foster the transition to more renewable energy system, the penetration of renewable energy into the grid by storing this energy and transporting it in easier forms, liquid forms, for example, through e-fuels, or gaseous form. So our vision is that among all the solutions that we have and that we have to work on to fight climate change, CCU can have a central part in this mix of solutions, and we are at a time where we have to figure and we have to take into consideration all those solutions whenever they make sense. So renewable energy generation, increase of renewable energy penetration in the energy system, electrification where it makes sense, increasing the efficiency and the energy efficiency of our process industries, using biomass under sustainability constraints, using hydrogen, carbon capture and storage also. So CCU can be part and become a key pillar of this transition to a sustainable economy, and can be of a benefit both to the climate and the industrial actors, but also to the citizens. So for those of you who don't know us, CO2 Value Europe has been formed in November 2017. It's the only association that is focusing on the valorization of CO2. I've explained the process, the cyclic process before. So from the upstream by capturing CO2, adding renewable energy and sometimes raw materials or waste, transforming it into an array of products which can be distributed using existing infrastructure, by the way. So we have partners from the complete value chain, which is our biggest advantage. So we have multinational companies, also large emitters, emitting sectors. We have SMEs that are green tech technology providers for the conversion of CO2. We have clusters, we have research institutions and universities that are looking at the lower TRL scale. So we have we're not a topical association representing the concerns of topical sectors. We are an association that is representing the concern of the development of the CCU industry. Just a couple of seconds on this slide to show exactly how diverse our membership is, with different types of companies at different sectors, different size, and different type. But I won't stay on that longer. In terms of our activities, we have three main pillars. So the first one is the collective intelligence on everything that is related to CCU technologies. So what kind of projects are ongoing? We're developing a database. You will see some examples later on. Who is behind them, what kind of technologies, what TRL level they are, their level of maturity. And this will help us to contribute to research and innovation road mapping activities, like for Processes for Planet, or the Clean Energy Technology Partnership, or the Synergy Initiative. And it is important for us that CCU has been gaining interest since a couple of years, more interest. So it is important that we gather all the scientific evidence that proves the important role that it could play into fighting climate change. So LCA studies, techno-economic analysis, this is what we try to gather under the pillar collective intelligence on CCU technologies. The second part of our activities is what we call upscaling and innovation. So connecting partners, helping them to bring about projects of demonstration, pre-commercial projects that really highlight the potential of CCU, and also attract funding, either EU funding, example, Innovation Fund, we will talk about it later, or even private funding through venture capitals, for example. And we also participate in EU projects ourselves. 3 examples here: Impacts 9, which I will talk a little bit later; Initiate, which is on valorizing emissions from the steel making industry to produce urea; Takeoff, which is on sustainable aviation fuels from CO2. So all of them, Horizon 2020 accepted, and 2 others have been accepted, and one has been just signed. The other one is expected now on CO2-based chemicals. And the third pillar is everything that is related to policy and advocacy and communication. So analyzing the policy context. As you will see later on, we are operating under a very complex framework, and we want to make sure that CCU is properly acknowledged, and that it is in a consistent way acknowledged, so that the industrial actors, the actors working on the CCU technologies, get the proper signal that they can still invest, they can scale up, they can transition. And of course, everything that is related to communicating, raising awareness about CCU, about CVE to different audiences. So that's in a nutshell CO2 Value Europe. So we see that CCU is discussed more in topical media, in more, let's say, generalized media. What is even more important is that it is studied more. And this is important so that the development of the CCU industry is founded on scientific evidence. So the last couple of years, we see more life cycle assessment studies being published to prove the potential of CCU. It's a nascent industry, so not a lot of data and information was available so far. So this is starting to change, and this is good because we need the scientific basis to be able to judge the development and to accompany the development of the CCU sector. But what is also very interesting is that CCU is not something of the future, of the remote future. It's something that is happening now. You see here some examples of high TRL pre-commercial projects that have been launched and are ongoing. I'm going to take a couple of examples. I already talked about Initiate. You have, for example, the Norsk e-fuel in Norway to produce sustainable aviation fuel from CO2. You have Jupiter 1000 in France that is producing e-methane to inject it to the natural gas grid. You have the Fast Carb project also in France for recycled cement aggregates for CO2 mineralization. You have a very specific example, tangible example from the Carbstone innovation of Orbix and Vito, that is a brick that you can walk on in Ghent, and I can tell you the name of the street. I don't have it in mind now, but I can write it in the chat later on. You have the North CCU hub that is taking place in Ghent, also to produce chemicals, methanol from CO2. You have the Zenit that has been recently announced to produce jet fuel directly from the air, capturing CO2 and producing sustainable aviation fuels. So a lot of projects that are ongoing and show exactly that Europe is the leader in CCU technologies, in providing alternative ways of producing our everyday products from emissions, turning a problem into a solution. I'm taking the example of Germany, which is a rather pronounced example because of the efforts that are happening in Germany in the area of CCU and power to X, P2X, with an extract from our database on different projects at different TRL levels. Whenever there is a pin, it means that there is a facility behind it. So These are higher tier projects. So you can see that there is a growing number of CCU projects all over Europe, and this is only a snapshot of one country. And from the EU perspective, there is support in this. There is support in research, innovation, and deployment. I have four examples here. The European Research Framework Program, Horizon Europe, the successor of Horizon 2020, where you can see several topics of particular interest for CCU. And I would like to take the opportunity to announce that tomorrow, sorry for the short notice, we have a funding workshop on exactly the Horizon Europe topics. I will put the link in the chat later on so that you can follow it if it's not too late for you. So we had from Horizon 2020 more than 80 collaborative projects without the latest, for example, the Horizon 2020 Green Deal also had similar topics of interest, and we don't know exactly the outcome of this yet. So at least 600 million euros have been invested in CCU related technology, and this trend will continue with Horizon Europe. We have the Innovation Fund that is funding pre-commercial, high TRL, innovative but mature projects, and CCU is part of the Innovation Fund. CO2 Value Europe is part of the expert group of the Commission on the Innovation Fund, and there we fund the additional costs, a percent of the additional costs that such an innovative project compared to a reference case. And the sectors that are referred to and relevant are the energy intensive industries. CCU is part of it, renewable energy sector, energy storage, and CCS also. So there are regular calls. The first two calls, one large scale call and one small scale call, have been already published, and the Innovation Fund will have a budget of 10 billion for 10 years with yearly calls. So a very important instrument also for higher TRL facilities. Then we have the IPCEI, important projects of common European interest, that allow member states to fund projects of transnational and a common European interest in ways that they can go beyond rules of state aid. So the member states get the approval of the Commission to support such projects beyond the state aid rules. And two main value chains there are the hydrogen technologies and the low CO2 emissions industries, for which an expression of interest has already been given by member states. And this can be an important instrument also for transnational cooperation. And then we have the CCUS set plan, where CCU and CCS is a priority in the strategic energy technology plan, and it helps actors come together and accelerate the deployment of CCU and CCS technologies. So that's one part of the picture. The other part of the picture is the complexity of the regular framework that we are operating under, especially now with the introduction of the European Green Deal. So there are a lot of legislative packages that have been newly introduced or that have been revised so that we are conform and fit for 55. So 55% emission reduction by 2030 and carbon neutrality by 2050. So some of them are quite represent a priority for CCU, either because they are very relevant or because they have not been acknowledged. CCU has not been acknowledged there. The ETS revision, for example, is an example of that. The RED II revision with the role of renewable fuels of non-biological origin and the access to renewable electricity. The sustainable taxonomy that has hints of CCU technologies in it, but not acknowledged in its totality as an economic activity that can benefit from the sustainable finance taxonomy scheme, and a whole list of other regulatory packages that are quite relevant. The carbon removal certification mechanism to see how CCU can be certified as a carbon removal process and which parts of CCU could help with that. The refuel aviation that will introduce hopefully blend targets for sustainable aviation fuels, also synthetic aviation fuels like CCU fuels. So a large non-exhaustive list you see here of a complex regulatory framework, and we are working on that to make sure that CCU is properly acknowledged, always on its scientific evidence. So we have some strategic priority like raising visibility and credibility on CCU, support the development of innovative projects through the Innovation Fund, propose concrete policy measures to give the right signal to the industrial actors, raise interest from private investors to complement public funding, standardization in case this helps, because CO2 quality can differ depending on the CO2 quality requirements, can differ depending on the conversion process. I would also like to point out our special efforts to quantify the role of CCU for mitigating climate change, and the work that we have done with our scientific advisory committee, composed of scientific experts in the field, members and non-members. So the picture you see above are non-members and below their members, and we made an expert review of the IPCC report, of the 6th assessment report, to make sure, based on scientific literature, that CCU is properly acknowledged, because if it's acknowledged in such authoritative documents, then it's also likely that it will be taken up by policymakers easier. So looking at the time, I hope I'm on time, but this was also my last slide. If you want to work with us, if you want to get involved in our activities, please reach out. And thank you for listening, and I'm happy to take your questions in the Q&A session.
Thank you very much, Anastasios, for your very interesting presentation on the general European policies on CCU, with a key role of CO2 Value Europe. So, as mentioned by Anastasios, let me repeat that at the end of the second presentation, there is a Q&A session. So, if you like, if you have some question for Anastasios, please you can type them in the question section. So let me introduce now the second speech in this webinar by Elvia Chavez, research scientist at Sintef Energy Research. So she will talk about the sustainability impact of CCU. So please, Elvia.
Thank you, Alberto, for the introduction. I hope that you can hear me. And good afternoon, everyone. My name is Elvia Chavez, and I work at Sintef Energy Research. And the work that I'm going to present today is performed in the ECCSELERATE project. So this is the second part of the webinar, Sustainable CCU Technologies Relevant for Europe and ECCSEL. And I will, in this talk, focus more in the sustainability impact of the different CCU options and how this can be evaluated. Okay, so the content is as follow. First, I will give a short introduction of how the CCU, a short introduction about the CCU and the products that can be obtained. Then I will present the approach to assess the sustainability of the CCU systems. Then I will provide an analysis comparing the different CCU options with the sustainability criteria that I will present. And at the end, I will briefly show some examples of mature CCU technologies which have been demonstrated at industrial scale and that they are commercialized. So let's start by the basic. CCU is a complementary way to handle the carbon dioxide, where the main goal is to contribute with climate change mitigation. For the CCU, once the carbon dioxide is captured from the industries, for example, the CO2 will be used as a feedstock and will be converted into new materials. So the carbon dioxide can be used directly. For example, in the food industry, CO2 is used as a refrigerant. CO2 also can be used as a solvent in different applications. However, direct utilization options are often not considered long-term sequestration options. And it has been argued also that a CO2-based EOR could be also considered as a promising direct utilization case. The carbon dioxide also can be converted or recycled through several chemical processes in feedstocks like urea or different kind of chemicals or solvents and polymers. Or it can be converted to fuels, as we can see in this list. Or the CO2 can be permanently stored through the CO2 mineralization process into some solid carbonate products like the aggregates for building or the CO2 cure concrete. And also it can be converted into new materials like carbon fibers or even graphene. So as I mentioned, this work has been done under the project ECCSELERATE, where the goal was to explore the CCU options taking into account their sustainability potential. So following this approach, one of the main factors that should be taken into account is about the potential to reduce the CO2 emissions, which means how much of CO2 can be avoided compared to other conventional value change or other CCU options. Another factor is the energy consumption, because it should be noted that the energy production will always have an environmental impact. Therefore, it's important to compare the energy consumption between the CCU process. Other factors like the economic benefits, other negative issues, and the maturity of the technology has also been considered in this assessment. So let's start by the first factor, CO2 emission reduction potential. So to have a sustainable impact, the net CO2 emissions from the CCU system must, as a minimum, be significantly lower compared to alternative value chains. And this criterion should be applied considering all the process involved into the value chain, which means the CO2 capture and the energy sources that are used, transport of the materials and the raw materials, and as well the CO2 emissions from the use of the product itself. Therefore, to evaluate the net CO2 reduction potential of a certain CCU is essential to evaluate the whole change from the CO2 capture to the utilization of the product. So, for example, for some chemicals and fuels such urea or methanol, they can store the CO2 only until they are used. So once the urea is applied as a fertilizer or the methanol is used as a fuel, the CO2 is released again to the atmosphere, corresponding to a storage duration of perhaps 6 months. Therefore, the overall potential for reducing the CO2 emissions will be relatively low, unless biogenic sources of carbon or direct air capture are used in the CO2 capture stage. The CO2 conversion of CO2 into polymers may also store the CO2 but in this case for several decades, perhaps as much as 50 years or more, depending on the development of reuse and recycle policies and technologies. For the aggregates for building and the CO2 cure concrete, once the CO2 is consumed or absorbed in these materials, the CO2 is not released again to the atmosphere. So this option can permanently store the CO2, and therefore this option is considered to have potential to contribute with the mitigation of the climate change. Another factor that I have mentioned is the energy required for the conversion. And here in this graph, which is a very classic figure, which shows the oxidation state for different molecules. So for many processes, this is strongly related with the energy input required for the conversion. So the lower, the better, which means that the molecules which are in the lower part, like the organic and inorganic carbonates, they require low energy to be converted from the CO2, and the case for methane, it requires a high energy. So in principle, the organic and inorganic carbonates and the polycarbonates also, and they are the most favorable CCU routes. Economic benefits. Economics are always an important aspect for the CCU technologies, but this includes costs for the capture, for the conversion, and the hydrogen production also. But in this graph, what I present is only the market size and the market price for the different products, which will also contribute to the economic benefits. So in this graph, the data which has been used in this graph has been used from the Carbon Next project. So the product with the highest market price is the polycarbonate and the polyols, as we can see in the figure. However, the market size, and in this case the European market size of these polymers, is very small. Methanol, for example, has a large European market size of around 7 to 10 megatons per year. But the product with the highest utilization market potential is the concrete industry, as you can see in this figure. But the amount of methanol, or the amount of these building aggregates that are produced from CO2 is very low. Currently, for example, the company Carbon Recycling International, which produce methanol in Iceland, produce only 5 kilotons per year, and this is much less than 1% of the market size. Therefore, to reach the CCU potential, new procurement policies and legislation targeting low carbon concrete and carbonate aggregates are needed. And here, this is a short list of some promising sustainable CCU options. So at the top, I have placed the building aggregates and the CO2 cure concrete, followed by the methanol, because it's a promising platform chemical for CCU that can be converted to a broad range of chemicals, in addition to the option of using it directly as a fuel. Followed again by ethanol via gas fermentation, which is also promising as a relatively low energy pathway to produce jet fuels using CO2 capture from industrial flue gases. However, to know how meaningful is the potential of these CCU routes, it is essential to carefully evaluate the whole change involved in the conversion process to find how much energy is required and how much is the net CO2 reduction potential. So I will show some examples of mature CCU technologies we have been demonstrated at industrial scales and are commercialized. So the CarbonCure is a company that has been established in 2012 and that produce concrete using CO2 as a feedstock. So how it works, their technology, first, what they are doing is that they are adding their equipment to a concrete plant. And second, the CO2 is captured from an industrial process or by direct air capture. Then this carbon dioxide is purified and delivered in pressurized vessels by commercial gas suppliers to the concrete plant. And then the CO2 is injected into the concrete mix. So once injected, the CO2 undergoes a chemical reaction known as CO2 mineralization, where the CO2 is converted into a carbonate mineral. So this technology produces a greener and, according to them, a stronger concrete. And we know that using this route, the CO2 will be effectively sequestered permanently in the concrete product. And the CO2 used in the process can either come from industrial sources or from direct air capture. Another example is the company Lancet Edge, which in the recent years they have shown several developments. So this is a company which is based in the US. And is one of the leaders of the technology, which is the gas fermentation. So the gas fermentation process is a technology in which the microorganisms can be used as a biocatalyst to convert gaseous feedstocks such as CO2 or syngas into chemicals and fuels such as ethanol. And also it can be converted to jet fuel through an additional process. So there are several commercial plants based on the Lancet Edge process and are in operation and in construction with a capacity of 60 to 70 to 65 kilotons per year range. This process, it's very promising because of the moderate temperature that they are using, which means less energy. And the fermentation step it's very flexible in terms of the gas composition, enabling the utilization of the CO or the CO2 utilization from a broad range of gas streams as I have listed here on the left. So these are just some of the reference that I have used for this study, and I would like to thank for your attention.
Thank you very much, Elvia. So I ask Elvia to keep the camera switch on, and Anastasios, if you could please switch on the camera for the question and answer session. So I see several questions now. Of course, if you have questions for the speakers, again, please type them in the question box. So the first question is for Anastasios. So which percentage of the produced CO2 in the world can be used today, and which technologies can be in the future scenario changers in terms of scaling up these quantities by 1 or 2 orders of magnitude?
So, which technologies? I think the technologies, it's difficult to say whether there will be some kind of a priority of technologies. I think it is wise to look at different fronts because you can get a wide palette of products by utilizing CO2. It feels that the legislative framework is in place or will be traditionally has been already there for fuels. Also probably because of the impact, because of the big volumes compared to chemical products. So a lot of projects leading to fuels have been announced and are at, let's say, demonstration scale, I would say, in the next 3 to 4 years. A lot of projects for methanol. Sometimes it's a little bit arbitrary to separate methanol to classify it as a fuel or chemical. But I think these are the technologies that will see more focus in the coming years. About the percentage that the question was, I'm not entirely sure that I understood. What is the percentage of uptake of CO2 was the question?
The percentage of the produced CO2 in the world that can be used today, and so the second part of the question was focused on the technologies.
Yeah, I'm not sure if I have a number, but the reality is that we have much more CO2 that we use nowadays, of course, and the interesting question is, how can we match the projected development of the capture sector, so that the CO2 captured can be directed to utilization. So for the moment, these are not matched. Of course, there is not only for the uncaptured CO2, but also for the captured CO2, the volumes that will be coming out of the capture part are for the moment significantly higher than the ones that can be utilized. And this exactly shows that there is a necessity to speed up the scaling up process of such utilizations technologies, so that they can treat enough of the captured CO2 to produce our products, make as much as possible, in a sense, closed loops of emissions being not emitted in the atmosphere finally, but captured, used, recaptured, reused in a kind of a closed loop system. So and all the residual emissions that are not used at the end will be directed to storage at some point.
Thank you very much. So the second question is basically a comment. So the amount of CO2 emitted from the fuel burned from enhanced oil recovery far outweighs the amount of CO2 stored. I don't know if you would like to reply to this comment.
Yeah, I have a general reaction that as CO2 Value Europe, we're not, let's say, supportive, if I can use this word, of the EOR, in the sense that we believe that the fundamental purpose of CCU technologies is to come to alternative non-fossil related products. So using CO2 to produce more fossil resources is not something that is in our scope. So we feel that CCU should be used for transitioning to less less fossil, more renewable systems in that sense.
Thank you very much. There are a couple of comments or questions about methanol. The first one, so the current production of methanol from syngas produces about 0.5 tons of CO2 per ton of methanol. And the production of methanol from CO2 and hydrogen from water electrolysis powered by green electricity uses some 0.5 ton of CO2 per ton of methanol. So basically, the carbon in the methanol becomes CO2 regardless where it comes from. So it matters how the methanol is made. The argument that methanol is only short-term storage is irrelevant. This is another comment. I don't know if you, Anastasios, or Elvia would like to reply to this comment.
Well, I can say something. So the argument about the storage time of CO2 in the different products is a valid, but at the same time, from the moment that an environmental benefit can be asserted, depending on let's say on a life cycle assessment of the product compared to its alternative, its fossil, then the storage time becomes also kind of irrelevant, as long as the alternative for the CCU product, environmentally speaking and proven from an LCA, is more favorable than the alternative product. So I don't know if this answers the question.
In my opinion, I think so. So thank you very much for this reply. Another question to Elvia. So what about the large energy penalty associated with direct air capture?
Yeah, I think this is something that has to be taken into account in the economy, but I think we need policies that can help to compete with other materials which are not made, which are not base CO2.
Thank you. Another comment. One challenge is that everyone cannot make methanol from CO2. The world needs a lot mature CCU technologies to diversify the industry. This is a comment. I don't know if you would like to reply to this comment.
If I understand correctly, the comment is that we shouldn't focus only to one product. If I understand correctly.
Yeah.
And
Yes.
I tend to agree with this comment. It depends always on the setting, geographical and not, but liquid fuels are a very good way of using existing infrastructure, storing renewable energy that would otherwise be very hard to transport using only hydrogen, for example, because you have a drop in fuel, as we say. You have a liquid fuel. You can use existing infrastructure, but gaseous fuels like e-methane, they can have the same function. They can use the natural gas grid. They can make let's say the natural gas grid more renewable by injecting a certain percentage directly into the grid. So I agree. We shouldn't focus only on one product. We also shouldn't focus only on energetic CCU processes. As Elvia showed, the market for materials out of CO2 is very big, and the challenge is the uptake rate of CO2 that I acknowledge. So CO2 mineralization still needs also research so that the uptake rate and the percentage is increased. But on the other side, you have a huge material potential with a huge fractions of waste materials like steel slags or bottom ashes or different waste materials that can be carbonated. So I think I would agree with the comment. The focus should not be on one particular sector or one particular product, but it might be that we have closer priorities in time. So, for example, if we're talking about the transport sector, it is possible that the aviation sector that lacks alternatives, because you cannot electrify now planes, or hydrogen as a fuel for planes is more challenging than liquid fuels. Then you will see also the policy being more directed to these sectors that might need CCU more than others. For the road sector, you might argue for or against electrification, but there is an alternative. For the aviation sector, you only have biomass fuels, and there you have the sustainability constraints, and there it is important to come up with CO2-based fuels that can have the same, let's say, climate mitigation effect. So there might be priorities, yes, but the idea is to target as much as possible products also in the chemical sector, providing an alternative carbon feedstock for the chemical sector. So as diverse as possible.
Thank you very much. So let me close with a last comment. With one of the attendees recommends to mention that the Global CCS Institute has issued a set of comprehensive life cycle assessment guidelines for CCU. So this is a very important remark.
It's not the sorry, Alberto, you said Global CCS Institute. It's the Global CO2 Institute, not the Global
okay.
CCS Institute.
Yeah.
It's the University of Michigan, the Global CO2 Institute, which indeed they have guidelines on LCA and techno-economic assessment also.
Okay, so let me thanks again Elvia and Anastasios for this webinar. Thank you all the speakers for participating. Let me just say that the presentations will be shared with all the participants. So again, thank you very much indeed, and see you to the next webinar in a few months. Thank you.
Thank you very much. Have a nice day, everyone.
Thank you.